Hello everyone, welcome to my channel. In this video, we are starting a complete compiler design series where I will explain each concept slowly, clearly, and with examples. So, let's begin. Every program you write in C, C++, Java, or Python, it never runs directly on your computer. Something powerful works behind the scenes, and that something is called compiler. So let's first talk about what is compiling. Before understanding a compiler, we must understand why compiling is needed. Computer do not understand high level languages as we discussed earlier that like C, C++, Java or Python. They only understand level binary instructions that is zeros or and ones. So compiling is the process of translating a high level source program into a equivalent machine level program that can be executed by the computer. So, what is the compiler? A compiler is a special system software that takes here sources, high level languages, that is C, C++, Python, and convert it into target program, that is machine level languages. So, it's just a system software which helps to convert our source code to target code. Okay, so it not only converts the high level language to machine level language, it also do many other tasks such as it checks syntax and semantics, it reports compile time error, also it generates optimized code. For example, if we write int a equal to b plus c, then the compiler converts this into assembly code or machine instructions understood by the CPU. So the compiler is divided into two main parts, which is analysis phase and synthesis phase. We call analysis phase to front end and synthesis phase to back end also. So this question is very much asked in all the exams, and uh, it's a conceptual question, but it always acts in com- college examinations. So analysis phase, we have the it reads the source program, analyze its structure and meaning, and generates IRs. What is IR? It is the intermediate representation, which is not C, C++, and also not 0 or 1, which is machine dependent language. IR is independent of both. So it includes lexical analysis, that is, converts characters to tokens. For example, if we see that in high level language we have written int a equal to b plus c. So here it convert in lexical analysis phase, it converts all the characters which is int a equal to b plus c it to into tokens. Then in syntax analysis phase, it checks grammatical structure, whether it is grammatically correct or not. For example, if we write int a equal to uh, b plus and remove this, so this will give us a syntax analysis. Uh, it will give us syntax analysis error. Okay. So then in semantic analysis, let me correct this first. Okay. So in semantic analysis, it checks the meanings and type consistency. For example, if we write int a equal to 2.3, then it will give a semantic analysis error. Okay. Then in intermediate code generation, it produces the machine independent IRs. Uh, as we have discussed above, a machine independent code generation means which is independent of machine dependent codes and also from high level languages. We will discuss all of these phases and phases of compiler video also in detail. So in synthesis phase, it has backend. The synthesis phase takes the intermediate representation and produce target machine code. It basically includes code optimization and code generation. Code optimization means it improves the performance and efficiency of any program. For example, in the little above phase where we have seen the intermediate code generation, the IRs are in are like three address code. We will discuss all these things in later videos, see how IR works, but here I will give a little brief of that. In IRs, it generates three address codes. For example, A equal to A plus B, then C equal to A not B, A star B, like that. But in code optimization, it reduces all the unnecessary codes. For example, if there is a code which says A equal to A plus 0, then let's say B plus 0, then it clearly means A equal to B. So this is what code optimization does. Okay, it removes all the unnecessary codes from the program. And in code generation phase, it generates the final machine code. Final machine codes, which is in the form of 0 or 1s. Okay, I hope it is understood. Okay, so next language processing system we will see in the next video. Okay, thank you.